Okay, before we talk about this table, I'm guessing that some or many of you used a two-step process to get the next salary for the teacher. Okay, you used a two-step process. So what I want everyone to think about is, could you devise a way in one step to get the next year's salary? Okay, could you devise a way in one step to get the teacher's salary 1 year later? So think about that. And if you want to work them yourselves, and then we'll talk about this in about a minute or two. So, can you come up with a one-step way to get the teacher's next year's salary? Okay, let's talk about the economist, the one on the left. Is there a one-step way to get the economist's salary the next year? Pretty easy, right? I mean, it would be harder to find a two-step way, right? So, how do we get these salaries of the economist the next year? Yeah, you just add 1,000, right? Is that true for every year? Yeah, that's true every year. So how is that salary going up? Goes up 1,000 every year. So, yeah, exactly. So after 1 year, it goes up 1,000. Next year, it goes up 1,000. Next year, it goes up 1,000. And he said, what kind of graph will we get? Linear. And what kind of rate of change is that? Constant rate of change, right? Constant rate of change. So this is kind of a different way of looking at constant rate of change, and that is thinking of it as growing by addition. Growing by addition. So we could think of this, we can call this like additive growth. That's what constant rate of change is, or linear growth. Whenever you increase, so which is input and which is output here?
Number of years input.
He wants number of years to be input and salary to be output. Agree with that? Yeah. Okay. So which of these two, input or output, are we looking at are we thinking about when we say additive growth? Output, right? So given any current output, to get the next output, you always add 1,000. Additive growth, constant rate of change, or a linear relationship. So what about here? What's the input and output for the teacher? Same thing. Input's number of years. So let's just, and the output is salary. Okay? So, the first year, the increase is 1640. Second year, the increase is 1705. Is this additive growth? It's not, because it's the amount that you add each year is doing what? Going up. the amount additional made is increasing itself. So it's not additive growth because the amount that you would have to add each year increases each year. Okay, but did you find a one-step, did someone discover a one-step way to get the teacher salary the next year? Yeah.
I think you do output plus output times 0.04.
Okay, so he said take the last year's, so 41K, we'll start with the first one. So 41K plus, what'd you do? 41
Times 104.
So those, if you did it by two steps, is this what you did? Did you find 4% of 41,000? And then did you add it to 41,000? Is that what you did? If you did it in two steps? Now we guess many of you did that. All right? You found that 4% increase, and then you added it back to the original amount. Is there a different way to do it?
I just multiplied it by 1.0.
No, I'm asking about people who did it in a two-step process. People who used two steps. You first found the percent, 4%, and then you added to the original. Yeah, sure. Okay. But look, if you take, so this is what you guys are talking about now, those who did it differently, you could factor out that 41,000. K stands for 1,000. I'm just shorthand. K is 1,000. If I factor that out, I'm left with 1 here plus what? 0.04. So in other words, it's 41,000 times so finding 4% of 41,000 and adding 41,000 is the same as many of you discovered, just multiplying by 1.04. So how can you see that process in the number 1.04? How can you see that that's going to give you a percent increase of 4%?
Because you're multiplying the 41 by 100.4%.
Okay.
So it's 100% of the original plus an additional 4%.
Right. So the 1 represents,
41,000.
yeah, you're not, it's the 41,000 from the previous year, and the 0.04, there's your 4% increase. Does it work for every year?
Yes.
Yeah. Because the salary is going up 4% every year, you can use the same multiplier for every year. And we learned about this on Friday. So what's being multiplied by 1.04? Output or input? And does it give you output or input? The next output. So it's this multiplier on a current output, which gives you the next output. And what is that multiplier called?
Growth factor.
The growth factor. Remember, this is from Friday. So when you have a constant percent increase, this is called the growth factor. Very important. When you have a constant percent increase, what kind of growth is it? Exponential, right? We said that when you have repeated multiplication by the growth factor to always get the next output, that's what characterizes, or that's what our exponential growth is about. So if this is additive growth, what kind of growth is exponential growth? Yeah, multiplying growth or multiplicative growth. Look at red. Okay, so it's the same thing as our pennies on the chessboard. What was our growth factor for the pennies on the chessboard?
2.3.
So we started with, what was the growth factor? 2. Remember, we always doubled the previous number of pennies. And so to get the next number of pennies on the next square, we multiplied by 2. So our growth factor was 2. This is the same thing. right? To get the next salary, you're going to multiply by the growth factor, in this case 1.04. What's new about this is now we're seeing that this multiplicative growth or this exponential growth also has this other idea associated with it of percent change. Percent change. What's the percent change for 1.04? 4%. Okay. What would the percent change be for 1.3? 3%? That'd be 30% increase. So if your growth factor was 1.3, if you kept multiplying the output by 1.3 to get the next output, that would be the same as 30% increase. Okay? What about 1.75? 75% increase. Okay, so where it gets a little harder is, what about with the pennies? The growth factor was 2, right? What percent increase is a growth factor of 2?
100%.
Okay, yeah, so it's a little tougher here. So what we're doing, what you did to get 75%, if you didn't, you might not realize this, but what you did was you looked at this, just the part that was without the 1. So you looked at 1.75 as 1 plus 0.75. The 1 represents what you had before. The 0.75 is that percent increase, so there's where you get the 75%. So we want to look at 2 as the same as 1 plus what? 1. 1 is what you had before, so this is the increase. What percent? 100%. So then there was another situation with the chessboard where it was tripling. We tripled the number of pennies each square. What would the percent increase be for tripling?
100%.
So tripling would have a growth factor of?
3.
A growth factor of 3, which would be 1 plus 2. What you had from before, here's the amount of increase, 2, which would be? So when you triple, that's the same as 200% increase when you triple. Okay, so additive growth is linear growth. Constant rate of change, additive growth. Exponential growth is based on what operation? Multiplication of the growth factor. Here's a nice thing, the growth factor doesn't change, just like in additive growth. It's constant rate of change. Now you have a growth factor, it's the same, given any output, multiply by the growth factor, gives you the next output. And now we see this association with that, with exponential growth or multiplicative growth. We have percent, a constant percent change. Constant percent change. Okay, any questions on that? All right, let's talk about the exam.